All right, and now we will go to example 420. This is the situation of two boxes and a pulley. This example is a combination between the Atwood machine and the object on a surface, because we can see that there's an object on a surface and the other object is there hanged, and they are both connected with a rope, assuming that the rope is weightless and it doesn't stretch. So we are assuming a perfect rope, and the rope is passing through a frictionless pulley. So this is kind of a combination problem. We want to see how do we solve this kind of a problem. First of all, we want to know what are the given things. There are two boxes, and here their masses are given, object A, object B, and also he's giving to you the coefficient of the kinetic friction. So mu K is given to be 0.2 without unit, you know that. And that's about it. So mass A is known, mass B is known, and mu K. That's it. And he's asking us to find the acceleration of the system. If you recall, we mentioned that the system will all move with the same acceleration. It means if object A is, let's assume like what he said, that box B moves downward, box A definitely will move to the right. So if the box B is going downward, box A is moving like this. Okay, so the object, so this thing is moving downward. So basically this is the motion. This is going here and this is going there. But the nice thing that all the system is moving with the same acceleration. So if object A is moving towards this direction with acceleration A, object B is moving downward with the same acceleration A. All right? So this is again, the system is moving in this way. If object B is going downward, object A will be pulled to the right. So if the value of the acceleration for object A is A to the right, for object B it will be the same A but downward. This is good. It will make our life easier, less variables. Now, so this is what he's asking. He's saying, what is the value of the acceleration of the system? How do we do that? We have two objects. For each object, we will have a Newton's second law applied for object A, applied for object B. If you recall, Newton's second law have X and Y, right? So anyway, let's make our life a little bit easier, and you will come to know, let me pick up my Word document. Okay, that's nice. Okay, let me pick up here and let me drag this one here all the way. Just a second. Okay, this is perfect. So we will divide. Actually, at the beginning, you will do it slowly till you will master it, and then it will take very few minutes from you later. You will say for object A, and then here for object B. And we are applying Newton's second law, which is summation of fx A x. And then we are also applying summation of fy m A sub y. Don't forget, this is not just m, it is m for object A. Same thing for B. Summation of f sub x is equal m ax, and summation of F sub y is equal ma sub y, and this is for object B. It's very important to write the notation properly. Do we have acceleration? Now you come to A. Where is the acceleration? Where is the movement of A? It is in the x direction, right? So, is there any movement for object A along the y direction? No. So immediately you just say that this right side is equal to 0, and this ax, to reduce the number of variables, it's our acceleration. Great. Let's come to B. Is there any kind of forces along the x-axis? No. Is there any movement along the x-axis? No. The forces on B, now we will come to know. It's Fg and the tension. There is nothing going on in the x-axis. So there are no forces along the x-axis. There is no motion along the x-axis. Good. So we don't have equation or force or anything along the x-axis for object B. But what about the acceleration? Yes, we have acceleration, and this is the acceleration of the system. Great. Don't worry now about negative or positive. Okay? Now, come back to object A. We will try to sketch the free body diagram for each one of them. So this is object A, and definitely there is ma times g. This is Fg for object A. And definitely there will be normal force. Alright, what is the other forces on object A? We have the tension force, and we have also the friction force, the kinetic friction, because it's moving. Wow, great, we got it. What about object B? Nicely, there is force, tension force, which is always towards the pulley. يعني this one is up, this one is to the right, and it's the same value. So Ft is same Ft. All right? Both of them are the same value, and they are both towards the pulley. What is the other force acting on object B? It is mb times g, which is the gravitational force or the weight of object B. Is there any other force on object B? No. Any friction? No. Any normal force? No. I see many students doing normal force on B here. This is not correct. And if you put it, definitely your solution will become wrong. There is no surface for object B is not acting on any surface. So definitely there is no surface reaction. So there is no B. There is no normal force on object B. Only two forces. So come back and apply our forces. Let's start. The force, and before I will start, I will remind you with something. I will write it here. Why? Because there is nothing here. Everything is 0. Whatever is with direction of motion will be positive, and whatever is against direction of motion will be our negative. Let's see how we will apply that. Where is the direction of motion? To the right. Okay, so we say Ft minus Fk, right? With against is equal to mass of object A times the acceleration of the system. Good. We got the first equation. Well, we can go one step further. What is Fk? It is mu k times Fn, which we don't know it yet. Let's come to the y forces. In this situation, we go up minus down. Okay? So, it is Fn minus mag is equal to 0. This is a very nice, lovely equation which will give us the value of Fn. Great. So, if Fn is given, can we rewrite this equation? Yeah, we can. We can. Just hold it. Hold it. Let me write. Or you know what? Let's write it down. This is equation 1. This is equation 2. Combine 1 and 2. Ft minus mu k times Fn, which is ma, times g is equal ma times a. Pay attention here. This is g. This is a. At the right side of the equation is the acceleration of the system. It's not g. It's not the gravitational acceleration. It's a. Many students, they say summation of fx is equal mg. Then mg cancel with mg. They will do all the mess here. This is the summation of fx in Newton's second law is equal mass times acceleration. Okay, what about object B? Now, up minus down because there is no motion along the y-axis. Now again, when we are in the y-axis, انتبهوا, here there is no motion. When we are again in the y-axis for object B, there is motion. So you follow this rule. With the direction of motion is positive, against the direction of motion is negative. Let's see. Summation of Fy. Where is the direction of motion? Downward. Downward. So what is the thing which is with the direction of motion? It's mbg. What is the force which is against the direction of motion? It's Ft. So we will write mbg minus Ft is equal to mba, not minus a, because we are doing it that with the direction of motion is positive. With the direction of motion is positive. Or if you want to go with whatever is down is positive, sorry, negative, whatever is up is positive, you will say Ft minus mbg is equal minus ma. That will work. I hope I didn't confuse you. I am following this. For wherever there is motion, whether it is x-axis or y motion, okay, whether it's along the x-axis or the y-axis, I am following that with the direction of motion positive, against the direction of motion is negative. So you have to follow one, then you will be safe. So this came from equation A and B, sorry, 1 and A. Now we have equation 3, okay? So can we put them near to each other? Move this equation here. I will put it in different color now. So this is our third equation, and underneath I will put Ft minus MUK MAG is equal to, just a minute, yeah, is equal MA acceleration. Now, can you tell me how do we solve these equations? How many unknowns do we have? M is known, E is unknown, okay, mu k is known, G is known, M is known, Ft is not known. So we have two equations with two unknowns. The two unknowns are Ft and A, but he's not asking for Ft, but he could. The only thing which we are looking for is to find A. We can do it from mathematics point of view, elimination and substitution, and you will be able to find A and then Ft. And thank you. This is math. You will be able to do it. All right? So this example is over.